Let's next tackle solving a rational equation in which we have a single fraction on each side of the equation. And you'll recall from an earlier discussion in this section that in this case the easiest way to eliminate the fractions would be to simply cross multiply. And that would be equivalent actually to multiplying both sides by the lowest common denominator of the two fractions. Now before we do this, let's consider two things. First, let's state any restrictions on x so that if that particular value occurs as a possible solution later, we would know that it would be an extraneous solution that we would have to throw out. So in this particular case, we can see, and we'll place this off to the side here, that x cannot be equal to 100. If x were 100, it would make the denominator of the first fraction 0, which would make the fraction an undefined. The other thing we might consider doing is reducing the fraction 15 over 100 to make our work a bit easier and the number smaller. So let's do that. If we divide both the 15 and 100 by 5, we can see that that fraction will reduce to 3 over 20. So we'll next cross multiply, and we will have then 20 times the quantity 18 minus x is equal to 3 times the quantity 100 minus x. If we distribute, we're going to have 360 minus 20x is equal to 300 minus 3x. Let's next subtract 300 from each member, which will leave us with 60 on the left-hand side, minus 20x is equal to negative 3x on the right-hand side. And now if we add 20x to each side, we'll end up with 60 being equal to 17x. And dividing each side by 17 gives us the value 60 divided by 17 for x. And since this does not match the restriction that we stated earlier, we're assured, unless we made an error in our computation, that this is a legitimate solution. Now let's next check this in the original equation, and it'll be a good review of how we might simplify a complex fraction. Now a convenient way to simplify a complex fraction like we have in the first step here, the 18 minus 60 divided by 17, all over 100 minus 60 divided by 17, would be to multiply the numerator and denominator by the lowest common denominator of all the fractions that we see. In this case, that would be 17. And you can see that off to the side here I've written 17 over 17, which is simply a form of 1. So we're not changing the value of the expression, but simply the way it looks. And hopefully it will simplify to something we can work with more easily. Now as we multiply by the 17 over 17, don't forget to multiply the 17 by both terms in the numerator and both terms in the denominator. So the 17 times the 18 will produce 306, and 17 times the 60 divided by 17 will produce 60. And in the denominator, the 17 times 100 will produce 1700. And 17 times the 60 over 17 will produce 60. And we hope this will simplify to 3 divided by 20. And the 306 minus 60 will produce 246. And the 1700 minus 60 will produce 1640. And if you divide both the top and the bottom here by 82, that will indeed reduce to 3 divided by 20. So we're sure that our answer of 60 divided by 17 is indeed correct.